Hello everybody. We are here to discuss about the step down choppers. Generally, step down choppers are those which are capable of converting one level of DC to another level of DC. So here the one level means the fixed voltage or the input voltage, and it is being converted to the variable voltage, where the variable voltage is always lesser than the input voltage or the fixed voltage. So that kind of converters are called as step down choppers or the step down converters. Here in the diagram you can clearly see in the input side the voltage is fixed, whereas in the output side the voltage is variable. So now coming to the devices which are used in the chopper, you can see the various switches here, namely GTO, IGBT, power BJT, power MOSFET in the low power application. Whereas when it comes to a high power application, thyristors can be preferably used. The dotted lines here represents the simplicity of the switch, and the current flow is represented by the arrow mark. And now coming to the operation of a step down chopper. Initially we can see the circuit here consists of a chopper or the switch, and then a freewheeling diode and a load. So here initially you can see a DC source voltage Vs and the output voltage as V0 and the input current as I0. Now you can see the step down chopper is also called as a buck converter, and it is used to reduce the input voltage at the output side. Coming to the operation of it, there are two modes of operation. First one is when the switch is on, and the second mode is the switch is off. Coming to mode 1, where the switch is turned on, we can see that the supply voltage Vs will directly appear across the load as shown in the figure. So here Vs is equal to V0. The output voltage is very same as that of the supply voltage. But when you consider the case where the switch is turned off, you can see here in the circuit diagram that the switch is turned off. Here Vs or the supply voltage is disconnected from the load, so the output voltage V0 is equal to 0. So you can clearly see that in the mode 1, when the switch is on, the input voltage appears same as that in the output voltage, but in mode 2, when the switch is off, the input voltage is completely disconnected from the load and the output voltage V0 is equal to 0. Now coming to the waveforms of it, you can see there are two waveforms here. One is the supply voltage Vs, which is a DC supply, and the other one is V0, which is the output voltage. And you can see here there are pulses which are shown in the output, where one condition is T on and the other condition is T off, meaning that when the switch is on, there is an output appearing, and when the switch is off, the output is 0. So here you can name it as T on and T off. Here totally the on time and off time is called as the time period T, which is represented in the waveform. You can see here T on is the interval in which chopper is on state, T off is the interval in which the chopper is in off state, and Vs is the source or the input voltage, and V0 is the output or the load voltage. Also you can see time period T is the chopping period or total time period, which is T on plus T off. So here we are supposed to say that the duty cycle D is equal to T on by total time period T, which is nothing but T on plus T off. Hence the total output voltage V0 will be equal to Vs into D, where D is nothing but the duty cycle or the duty ratio appearing at the output, and the value lies between 0 to 1. The value of D always lies between 0 and 1. So hence mathematically when you see that V0 is equal to Vs into D, you can say that always the output voltage will be lesser than the input voltage. Thank you.